Hello everyone, I am Dr. Sudhansh Sharma from School of Computer and Information Sciences, Indira Gandhi National Open University, and today we are going to discuss determinants. It is an introductory session and we are going to have a series of sessions about the mathematical topics, and to begin with we are going to start with determinants and introduction. Now, this is actually the component of BCS 12 basic mathematics course, and which is generally required in BCA program, and it is also a bridge course for PGDCA, that is postgraduate diploma in computer applications. Now, to begin with, we should understand that why we are having actually multiple blocks in course BCS 12, Algebra 1, Algebra 2, and many more. So this is the part of Algebra 1, and this is the very first unit. Now, we need to understand what are determinants, what is their relevance in context of your computer science. Because generally students don't understand that why they are supposed to understand mathematics as a part of computer science. So in order to understand this, firstly we need to understand that there are three types of words. There is a real word, there is a mathematical word, and there is a computer word. So mathematics acts as an interface in between the real world and the mathematical and the computer world. Likewise, there are different components and which are contributing to different applications in computer science. Say we are having set theory and entire database management system and many algorithms like a priori algorithm is very much dependent on the understanding of the set theory. Over here we are going to discuss about matrices and determinants, and they are very important if we say go for the understanding of computer graphics or digital image processing or geographical information systems, because they are actually the mathematical elements which helps us to store the information. Likewise, so for better understanding, say you are having an image. So in image the pixels are there. So these pixels are holding some value, which value comprises of the contrast, intensity, brightness, color, hue, saturation, and many more things. So that means a matrix, a picture is a matrix of pixels, and each pixel is carrying some value. So that means a picture is a two-dimensional information. So that means we are having a combination of rows and columns, and these rows and columns defines the order of the matrix and determinant. So need not to take more time. Let's begin with, we are going to have an introductory session of determinants, and over here the objectives of the today's session are to define the term determinant and to understand and evaluate the determinants of order 2 and order 3. Apart from this, in this session we are also going to discuss about the properties of the determinants. So what is a determinant? So determinant actually, as I said, that say in a picture we are having a multiple number of pixels, and in the pixels we are having the information which is about their brightness, contrast, intensity, color, in hue, and many more things. So determinants are in fact the numerical values associated with the square matrices, and matrices with the number of rows and columns. So square matrix are the matrix which are having the same number of rows and column. So you might be thinking that we are talking about determinant, suddenly the matrices are coming into picture. So those who are having a little bit of the background of the mathematics, the matrices relates to the vector component, whereas the determinants relates to the scalar component. So they both the things goes hand in one hand. So likewise, the fundamental definition of vector says that a vector is equal to magnitude of a into a unit vector. You can say that we generally say it in this way, that if we are having a vector a, just wait for a moment. Say we are having a vector a, and so this is vector a, and this vector a can be written as magnitude of vector a into a unit vector. So this section, this vector is represented by the matrices, and this is the magnitude, and this is represented by the determinant. So determinants have got different rows and columns. So depending upon the number of rows and number of columns, we are having the order. Likewise over here, n rows are there and n columns are there, then the order of the determinant will be of order n. So this is the determinant. This is the determinant of order 2 because it is a square matrix having same number of rows and same number of columns, 2 number of rows and 2 number of columns. So it is a determinant of order 2. And generally the determinants are used to represent the linear equation. Likewise over here we are having two linear equations, a1x, we are having a1x plus b1 and a2x plus b2. So we can rewrite them as a1x plus b1 equal to 0 and a2x plus b2 equal to 0. Taking the components aside, we can always write them as a1 a2 and or you can say a1 b1 and a2 b2. So this is the determinant and we are multiplying it with x. So you can say that in order to evaluate this you need to have multiply a1 with b2 and a2 with b1. So this solution turns out to be you multiplying this with this and this with this, you will get a1 into b2 minus a2 into b1. So this will be the solution of this determinant. So determinant is given to you a1 b1 a2 b2, cross multiplying, that is a1 into b2 minus a2 into b1 will be the final expression which is evaluated after the opening of this determinant. Now this is having 2 rows and 2 columns, so this determinant is of order 2. So that means you can always say that the determinant a1 b1 a2 b2 is actually this into this minus this into this. So a1 b2 or b2 a1 minus a2 b1, and this is the determinant of order 2. So let's understand that how we apply the this understanding of determinants to solve some numericals. Likewise over here we are having a question, solve this 3 5 minus 2 6. So what we will do, 6 into 3 minus 2 into 5. So 6 into 3 minus, so minus 2 into 5. So 6 into 3 turns out to be 18 minus 5 into minus 2 is minus 10. So 18 minus 10, that is 18 plus 10, this turns out to be 28. So this determinant evaluates to the answer 28. I hope you understand. Now we can it is not always that the determinant values need to be only the numbers. We can have the expressions also. Likewise in other determinant we are having, it is again a determinant of order 2, wherein 4 expressions are given: 1 minus t square upon 1 plus t square, 2t upon 1 plus t square, minus 2t upon 1 plus t square, and 1 minus t square upon 1 plus t square. Now applying the same concept, multiplying this by this and minus this into this, what you will get, 1 minus t square upon 1 plus t square into 1 minus t square upon 1 plus t square. So this turns out to be 1 minus t square upon 1 plus t square whole square. Now minus sign is already there, minus sign, because we are having minus 2t. So this will be turning out to be minus of minus 2t upon 1 plus t square into 2t upon 1 plus t square. So this turns out to be, because minus is outside there, minus is also inside there, this turns out to be positive. As a result of which 2 into t, 2, that is 4t square will be in the numerator, and we are having 1 plus t square upon whole square in the denominator. As a result of which we are going to solve, taking the LCM all together and solving the expression, you will get the answer to be 1 plus t square whole square upon 1 plus t square whole square, and this cancels out, the numerator and denominator values cancels out, as a result of which the answer turns out to be 1. Now we are having linear equations of say 3, we are having say 3 linear equations, likewise which one is shown over here. say over here we are having a11x plus a12y plus a13z is equal to b1. Second equation is linear equation a21x plus a22y plus a23z is equal to b2, and a31x plus a32y plus a33z is equal to b3. Now taking the coefficients all together, we can always write these equations as a11, likewise written over here, a11, a12, a13, similarly a21, a22, a23, a31, a32 and a33. Now there are 3 rows and 3 columns, as a result of which this is a determinant of order 3. And the elements of the determinant are actually the coefficients of x, y and z variables. So we will learn how to solve the determinants of order 3. Likewise over here, let's solve this determinant which was discussed in the earlier slide. So this expression, firstly we need to understand that the polarity of the sign in normal determinant varies, plus and then minus and then plus, similarly minus and then plus and minus. Now this is sometimes the solution of this problem, that there is a variation in sign, is handled by the understanding of the mechanism of minors and cofactors. So this is sign plus, this is minus and this is plus. So the first intersection of row and column happens at a11. So a11 is taken care over here, and the remaining determinant after this is this a22, a23, a32, a33. Now solving this, that means a22 into a33 minus a23 into a32. So this is what is written over here. First sign is positive, a11, positive a11 into a22, a33 minus a23, a32. Similarly, second sign is negative. Second sign is negative. So negative sign is placed over here, and next intersection is this. Next intersection of row and column is a12. So a12 is written over here. And after this, after eliminating first row and second column, we are left with a21, a31 and a23, a33. So the solution will be a33 into a21 minus a31 into a23. So this is what is written over here. So a21 into a33 minus a31 into a23. Similarly, the last thing will be positive sign, and this is positive sign. Last expression is a positive sign, and the number is a13. So a13 is written over here. Remaining elements will be, remaining elements are, these are the remaining elements. So that means a21 into a32 minus a22 into a31. So this is the final. So overall solution of this determinant is given by this expression. So you just monitor that whatever is parenthesized, this parenthesis is actually this determinant, this parenthesis is actually this determinant, and this final parenthesis is actually this determinant. So, but you need to understand that there is a fluctuation in the sign. The first sign is positive, the first sign is positive, the second sign is negative, and then the third sign is positive. So we will take care of this fluctuation in sign by the use of understanding the concept of minors and cofactors. And before that, let's understand how to solve the determinants of order 3. Now here is an example wherein we are given the first row of the determinant is a01, second row is 0b0, and third row is 10c. So first is a01. So intersection of first row and first column. What is this? This is A. So A is taken care over here. After taking care of A, the remaining determinant is B00C. So this is B00C. So in order to evaluate this, we need to multiply this with this and this with this. So B into C minus 0 into 0. So first expression will be A into B into C. So this solves to A into B into C. Now taking care of the second row and first row and second column. So first row and second column, so the intersection point is 0. So this is 0. So anything multiplied by 0 is always 0. So this is not taken care of. So this part is ABC. Second part is 0. And now we will take care of the third part. The third part is first row and third column, which is 1. So 1 is written over here. 1 is written over here. And the remaining determinant is 0B10. So 0B10, evaluating 0B10, we will get this into this minus this into this. So this is minus B. So the overall solution turns out to be ABC into minus B. I hope you understand how we solve this expression and we got solution to the first problem. Now extending the discussion to the next question, likewise over here, the first row is 1ABC, second row is 1BCA and third row is 1CAB. Now if we take the intersection of first row and first column, the intersecting point is 1. So intersecting point is 1. And the remaining determinant is this. That is BCA and CAB. So in order to solve this, what we are supposed to do? This into this minus this into this. So that means ABC minus AB square minus AC square. The first expression multiplying this by this, multiplying this by this. So what we will getting? A into AB into B. So that is AB square. And multiplying this into this, that is CA into C, that is AC square. So this is what is the solution of the first expression. This is similarly you can solve for the other components, this component and this component, and you will get the expression. This is the expression for the second component and this is the expression for the third component. So rearranging and solving, you will get the final solution as this. So this is how we solve the determinants of order 3. Now we need to understand the concept of the minors and cofactors. As we had already learned that when we are solving the determinants, then there is a fluctuation of sign and we find that the sign is alternating from plus to minus and minus to plus. In order to preserve this, that means we need to have the consistency in the sign. We need to have the understand the concept of the minors and cofactors. So what are minors and cofactors? The definition says that if delta is a determinant, likewise over here, if delta is a determinant, then minor Mij of the element Aij is a determinant obtained by deleting ith row and jth column of the determinant delta. So let's understand this. Now delta is the determinant shown over here. So after deleting ith row and jth column, so this is first row, first column. So removing first row and first column, we are remaining with this. So this is nothing but minor M11. So minor M11 will be A22, A23, A32, A33. Just repeat the definition, just re-understand the definition. If delta is the determinant, then minor Mij of the element Aij is the determinant obtained by deleting ith row and jth column. So firstly we remove the first row and first column, and after removing this we are remaining with these elements, that is A22, A23, A32, A33. So this is nothing but minor M11. Similarly, second row and first column. So second row is this and first column is this. So removing this, you are remaining with A12, A13, A32, A33. So all are mentioned over here, and this is nothing but minor 21. So minor of the element A21 is M21, and which is given by this determinant. Okay, you got it. I think on the same line you can calculate the value of M32 also, and other values, M33 and other values also. So that means these values are actually representing the determinant section. So we can always say that this is nothing but minor M11. This is nothing but minor M12. This is nothing but minor M13. So we can rewrite the evaluation of the determinant delta in terms of minor in this format. That is, delta is equal to A11 into M11 minus A12 into M12 plus A13 into M13. So again over here you are observing that there is a fluctuation in signatures in the sign. This is plus A11 M11 minus A12 M12 plus A13 M13. The sign is moving from plus to minus and minus to plus. So how to handle this problem? In order to handle this problem, there is a concept called cofactors. So firstly we need to understand that what are cofactors. So cofactors are, the definition says that the cofactor Cij of the element Aij in the determinant is defined to be minus 1 to the power I plus j Mij, where Mij is the minor of the element. So minor of the element Aij. So this is the fundamental formula which relates to the calculation of cofactors from the minor. That is, Cij is equal to minus 1 to the power I plus j into Mij. So as a result of which, say we are having the value A1, say we want to calculate cofactor for the element A11. So yes, A11, and this will be equal to, that is, this cofactor will be equal to C11. So C11, so minus 1 to the power 1 plus 1 into M11. So this will be positive. So it's positive M11. Likewise over here, say, just refer to the earlier slide. We are having the next element is A12. So this was the let's focus on this part. Let's focus on this part. So C12, what will be C12? C12 will be equal to minus 1 to the power 1 plus 2 into minor of A12. So this will be equal to minus of M12. So if we substitute minus of M12 over here, then that means minus of M12 will be replaced by minus of M12 will be replaced by C12. C12. So you can better understand by replacing the values of minors with the expression for the cofactors, you will find that the sign is not fluctuating. Now we are having, that is, delta, which is always equal to A11 C11 plus A12 C12. It should be C12, and it should, and apart from this, A13 into C13. So this expression, it should be 2. This should be 2. So A11 C11 plus A12 C12 plus A13 C13. And this is actually, that means there is no fluctuation in the sign, and the things are being balanced by the help of the concept of cofactors. So we can understand how to calculate the values of minors and cofactors. Likewise over here, one example is asked to determine the minors and cofactors. Write down the minors and cofactors of each element of the determinant delta, and the delta given to us is this. This is the delta which is given to us, 3 into 3 minus 1, 2, 5. So first minor will be removing first row and first column. First row and first column is removed, then the first minor will be 5. So second row and first column, so M21 will be, the remaining element is minus 1. So second element is M21 is minus 1. On the same line, M12 will turn out to be 2, and M22 will turn out to be 3, because removing second row and second column. So remaining element is 3. So remaining element is 3. And we know that there is a relation between cofactor and minor, and that is Cij is equal to minus 1 to the power I plus j, minus 1 to the power I plus j into Mij. So substituting the value of I and j, you will find that the C11 turns out to be 5 only, because C11 will be having minus 1 to the power 1 plus 1 into Mij, that is 5 only. Minus 1 to the power 2 will be equal to 1 only, because it is positive. Minus 1 square is plus 1. Similarly, C12 will be equal to minus 1 to the power 1 plus 2 and into 2. So this turns out to be, that means minus 2. So C12 turns out to be minus 2. I hope you understand this, that how to calculate the minors and the cofactors. Now there are some of the properties, and these properties are listed over here. The reflection property. The reflection property says that the determinant remains unaltered if its rows and rows are changed into columns and columns are changed into rows. So if we interchange the rows and columns, then the value of the determinant remains unaltered. It is as it is. Apart from this, we are having the all zero property that says that if all the elements of the row are 0, then the determinant turns out to 0. Obviously, if any of the row or any of the column values all are 0, then we are continuously multiplying the entire determinant with the help of with 0, and multiplying any value with 0 turns out to be 0. There is a repetition property or the proportionality property, which says that if the element of a row or column are proportional, that means they are identical to the elements of some other row or column, then the determinant is 0. So if the two rows and columns are identical, or if there is repetition, that is one row or column is multiple of the values of the other row or column, then the resulting determinant will be 0. Apart from this, we are having the switching property. That means if we interchange any two rows or columns of the determinant, then the sign changes. So whatever is the value of the determinant, the sign of the determinant value, the outcome value will change if we interchange the two rows or columns of the determinant. So apart from this, we are having the scalar multiple property, and which says that if all the elements of a row or column of a determinant are multiplied by a non-zero constant, then the determinant get multiplied by the same constant. So if we are having, say, some determinant which turning out to be, say, some value, say x, and we are multiplying all the values of the determinant, say, by 2, then obviously the final result of the determinant will turn out to be 2x. The sum property is very self-explanatory. Likewise, say we are having a determinant a1 plus b1 c1 d1, a2 plus b2 c2 d2, a3 plus b3 c3 d3. Then this can be re-represented in the form where a1 a2 a3 and b1 b2 b3 can be written separately as a separate determinant. So that means this expression can be rewritten as a1 c1 d1, a2 c2 d2, a3 c3 d3 plus b1 c1 d1, b2 c2 d2 and b3 c3 d3. On the same lines, the property of invariance and triangular property is there. The triangle property is very important, which says that if on either side of the diagonal, say all the elements are 0, then the evaluation of the determinant can only be done by multiplying the diagonal elements. Likewise, we are having the two examples over there. Here in the triangle property, we are having a1 a2 a3 0 b2 b3 0 0 c3. So the upper triangular components are non-zero, whereas lower triangle components are 0. So in this case, the value of the determinant will turn out to be a1 b2 c3, that is multiplying the diagonal elements. Similarly, if we are having, say, the lower triangle matrix, likewise we are having a1 0 0, a2 b2 0 and a3 b3 c3. Over here the upper triangle elements are 0 and the lower triangle elements are not 0. As a result of which the result of the determinant will be obtained by multiplying the diagonal element, that is a1 b2 and c3. This is a very important property, and by applying these properties you can solve a number of numericals. And here is a simple numerical, and if you understood all the properties, you can, and the way to solve the determinant, you can simply apply the concept which you learned in this session, that how to solve a determinant and what are the different properties. You will get the answer that to this equation, and you can prove this by the steps shown over here. I hope you understood that what is determinant, how it is related to the field of computer science, how it is different from matrices, how to evaluate the determinants of order 2 and order 3, and you also learned about the different properties of the determinants. We will extend this discussion in the subsequent sessions, and for meanwhile, it is suggested that you go through some of the units which are available on the EGNOU course under the course BCS 012. Basic Mathematics. Thank you.
इंदिरा गांधी नेशनल ओपन यूनिवर्सिटी बहुत सारे ऑनलाइन कोर्सेज चलाता है और ये ऑनलाइन कोर्सेज एक विषय के लिए नहीं, कई विषयों के लिए हैं और जितने भी ये विषय हैं ये रेलेवेंट हैं, समय समय पे अपना ये बदलाव भी लाते रहे हैं। मैं यहाँ पे आपको बताना चाहूँगा कि 35 साल पहले जब मैं सिविल सर्विस परीक्षा की तैयारी कर रहा था तो मैंने इंदिरा गांधी नेशनल यूनिवर्सिटी के